Okay, so as I mentioned in the last video, I'm going to abandon the pick-based approach and start to replicate this using an Wattmeter 328. So I've got a few steps that I'm going to do. The first one is to basically get that 2.5 volt low dropout regulator. So here's a data sheet for that, and I've actually got it already mounted, so there we go, there's the focus, on a SOT 23 to DIP 10 board here. So I'm going to use this. So I'll get that installed. I'll check that it's actually outputting 2.5 volts. The next step after that is I'll hook it up to the Wattmeter. Actually, I've got just a simple shield here, so I'll be using that in this part of the video. So I'll confirm that I can read the 2.5 volt signal, and then after that on the proto board I will hook up the existing 8307 board that I used in the last one. I'll get that installed on the proto board. I'll also here's the LF398 ready to go. And then here's the plus or minus 12 volts and the 5 volt signal here that I'm driving from the circuit that I built up before. So once that's all hooked up, I'll be able to input the signal from the signal generator, and we'll be able to read some of those voltages using the analog to digital pins on the Arduino. So that's to come. First step is the 2.5 volt regulator. Okay, so the 2.5 volt regulator is installed. You can see here, this is the output side. There's a 1 microfarad cap there. There's a 470 picofarad cap right behind it. That's the bypass cap. And then here's ground, and here's 5 volts. So this is the output here, so let's probe across this capacitor here. And as you can see, we have 2.524 volts coming out there. So that's the 2.5 volt regulator completed, and we can move on to the next step. Just before we go too much further, I thought I'd kind of show my schematic for kind of where I'm headed, and I'll include some Eagle files on my GitHub site too, if anyone's interested in replicating this. So anyway, this circuit obviously is a copy from the PIC-based one, except I replaced the PIC with an Wattmeter 328. So here's the LDO that provides the 2.5 volt reference source. Here's the two LF398s that are used to sample and hold the signal from the 8307s, which isn't on this board. And then here's the kind of power circuitry for the Wattmeter itself. And then I've got basically some pinouts here for off-board connections. So this one is for the 5 volt ground, the plus or minus 12 volts. This one's for an external encoder. If I think I might need an encoder on this to just do some configuration. And then this is the connections for the 8307, the off-board stuff. So anyway, this is where I'm headed. As I said, next step is I've got this on the proto board. Going to connect this up to this ADC pin here, and then we're going to read the result. So here's the low dropout regulator connected up to analog to digital pin A0 on the Wattmeter, and you can see here I'm actually just reading the raw value off there, and it's about 519. Now it's 519 out of 1024. So that's how much resolution you have on that. So that's working. Just to confirm that we kind of have something valid here, let me pull that out and connect it to ground. And you can see there it goes to 0. So let's pull that out, put it back in, put it back into there. And it's moving around a little bit. I guess that's to be expected. This, it's quite a bit of length in the wire here. But just panning over to the code, and the code's dead simple, of course, as you'd expect. I'm using this I2C library for the liquid crystal display. So, basically, it's a lot easier. As I mentioned, you've only got 4 wires to the LCD, the SDA, SCL, and then 5 volts and ground. So it's a lot easier to hook it up. And then simply I'm in a loop just reading that reference voltage and printing it out. So that's that all working. I guess I'll move on next to hooking up the LF398 to the Arduino, and we'll take it from there. Okay, so I've got the 8307 board connected in here. I've got the LF398 installed, and so let me just describe the the various connections going on here. So this board you're familiar with from the previous video. The red wire is a 5-volt supply to the IC on the board. The black wire is ground on the board. White is the signal coming from the 8307. That signal then gets fed through to pin 3 of the LF398. The LF398 is connected to both minus and plus 12 volts. And then I've got the sample and hold signal pulled high. So what that does on the sample and hold is pulled high is it just passes through whatever it gets on this pin, it passes through the output pin. And then this white wire snakes off to pin analog to digital pin A2 on the 18 mega. So I've got the signal generator set over here to 5 megahertz, 0 dBm, and of course all this is relative, right? So this is just a representation of the voltage here. So you can see it's 461. Out of 1024, so each of the analog to digital pins goes from 0 to 123 on this particular board. So let's vary that that input power. Let's go all the way down to minus 60 dBm and see what the resulting number is. And you can see that that's now changed to 146. So let's go up another 10 dBm to minus 50 dBm. And that goes up to 198. Let's go up another 10 dB to minus 40 dBm. 249, minus 30 dBm. 303. So it's about 50 to 53 points per 10 dBs on the signal generator. And so I've measured all the way from minus 70 to plus 15 dBm. Let's go to 15 dBm and see what that is. So that's all the way up at 538, which is a little bit above the reference voltage. So everything's working fine. I do have that linear relationship between the power in dBs and the output voltage to the analog to digital pin on the Atmega. What I might do now is, this is a bit of a dodgy setup here. The pins are all sort of loosely attached here, and I'm getting kind of variations. So what I'm going to do as a next step is, I have a board designed in Eagle. I will etch that out, and we'll get the components installed onto that board instead of using the proto board setup. I also have on the board an in-circuit system programming pin, so I can continue to kind of program this and experiment with this, but I'll have much firmer connection to the various points on the board. So anyway, that's what I'll do next. I'll wrap this video now, and we'll take it from there. Just before moving on to kind of putting this on a board, just walking through the code, it's really simple. But anyway, so I've just added this new voltage pin here. So sorry, let me pan up to that. I've added the new A2 is the analog to digital pin I'm using for the forward voltage. And then you can see down here, I am just I've just got some additional code to read and print the value on that pin. So very, very simple stuff. I mean, obviously, once I get it onto the board, I can make the code a little bit more sophisticated, perhaps include some calibration and so on and so forth. But anyway, I'll move on to the next video now.